to my YouTube channel. I am Hajra Mughal and today we will be continuing our lecture series on Mdcat and Ecat preparation for physics. I am glad you are joining me and I look forward to helping you achieve your academic goals. Let's begin. Students, in our previous lecture, I provided a comprehensive list of topics that you need to cover to prepare for your Mdcat and Ecat exams. Please review that list and let's move on to today's topic. Today we will be practicing MCQ focused on circular motion. So let's get started. To master multiple choice questions on this topic, make sure to review the following essential topics like the basic terminologies like angular displacement, velocity, acceleration, time period and frequency, relation between linear and angular quantities, centripetal acceleration and centripetal force. By covering these key areas, you will be well prepared to tackle multiple choice questions with confidence. So let's get started. Okay, so MCQ number 1 is a man wear 15-gram stone around his hand by a 2-meter string. So if I make a data that the mass is given as 15 gram, and if you convert into kilogram, why we are converted into kilogram? Because kilogram is SI unit, so it will be divided by 1000, so it will become 0.015 kg. Okay, 2 meter, so it's a radius, 2 meter. What is the force applied by the stone on hand if it completes 1 revolution around hand in 1 second? So you have to calculate force, and one more thing that is given is the angular speed, and it is given that 1 revolution is covered in 1 second. So we know that revolution per second is not SI unit, so we need to convert it into radian per second. So we also know that 1 revolution is equivalent to 2 pi radian. So when I divide it on both sides by second, so it will become, wait a second students, so it will look like 1 revolution per second is equivalent to 2 pi over radian per second. So I can replace 1 revolution per second by 2 pi radian per second. Okay, so now what should be the formula? We know that force is equivalent to MA, and if you have recall your previous knowledge regarding circular motion, so you know that A is equivalent to R omega square according to centripetal acceleration. So if I substitute all the values, so M is equivalent to 0.015 and R is 2 and omega is 2 pi square. It is 2 pi square. Okay, so when I solve it, 0.015 into 2 into 4 pi square, and 2 into 4 is 8. So basically you have to multiply 0.015 into 8 pi square. So when you multiply it, so it will be equivalent to 0.12 pi square. So correct option is B. And how you are going to multiply? Look at here students, it's simple. 0.015 multiply by 8. So 5 8s are 40 and 8 1s are 8, and when you add it into it will become 12. So 2 and the power 1 over here, so it will be 1, and this 0 decimal is same, so it will be 0.12. Direction of angular velocity is parallel to the plane, perpendicular to the plane in which body moves, lies in plane, none of these. So according to the concept of the angular velocity, students, we know that the direction of angular velocity is always perpendicular to the plane. So the correct option is B. Okay students, the next MCQ is if a stone is moving in a circular path such that its angular velocity is increases from pi by 4 radian per second to pi by 2 radian per second. So students, we will make a data first that the initial angular velocity is given as pi by 4 radian per second and the final given as pi by 2 radian per second. At the end one of the diameter, at the end of one of the diameter, what does it mean? It means the distance covered is given as pi radian. How we know that in a complete circle the distance covered is 2 pi radian. So when they are asking at the end of one of the diameters, so it will be pi radian, and we symbolized as theta in angular quantity. Okay, what is the angular acceleration? The symbol of angular acceleration is alpha, and we have to calculate alpha. So students, how to solve this? We know the equation, one equation of motion, that 2as is equivalent to vf square minus vi square, and if I write this equation in angular form, so it will be 2 alpha theta equals to omega f square minus omega I square. If I want to calculate alpha here, so alpha will be omega f square minus omega I square over 2 theta. Omega f square is pi by 2 whole square minus pi by 4 whole square, and 2 theta is 2 pi. If I solve this, pi square over 4 and minus pi square over 16 and 1 over 2 pi is already in division. So if I take LCM, so the LCM will be 16 here, and it will become 4 pi square minus pi square into 1 upon 2 pi. So 4 pi square minus pi square will be 3 pi square, and 2 into 16 will be 32, and the pi will be cancelled out with the pi, so it will be 3 pi over 32. So the correct option is B. If a body is in uniform circular motion, then there is dash acceleration, centripetal acceleration, tangential acceleration, angular acceleration. Both A and C mean centripetal and angular acceleration. So students, remember that if a body is in uniform circular motion, then its angular speed is constant. Angular speed means the omega is constant, and so is the magnitude of its linear velocity. That is why there is no angular and tangential acceleration. There is only centripetal acceleration because of the centripetal force, which is responsible for changing the direction of the velocity. So the correct option is the centripetal acceleration. Okay, so next MCQ is the angular speed of a tire of a car is pi by 3 radian per second. So we will make data as we are reading the MCQ. So the angular speed is given as pi by 3 radian per second. What is the distance covered by the car in 60 seconds? What is the distance covered? So we have to calculate S. In 60 seconds, the time is given 60 seconds. If the radius of the tire is 40 centimeter, and we know that centimeter is not an SI unit, so we need to convert it into meter, so it will become 0.4 meter after dividing it by 100. So students, we can use the formula theta equals to omega t to calculate theta, and then we will use S equals to r theta to find out the distance. So omega is given pi by 3 and the time is given as 60. If you cancel out these two, so it will be 3 2s are 6, so it will be 20 pi radian. And if you substitute this value over here, so r is 0.4 and theta is 20 pi radian. So when you multiply it, these two, so it will be 8 pi meter. How it will be 8 pi? Look at here students, 0.4 multiplied by 20. So when you remove this point, so there will be a 10 number over here, and 0 will be cancelled out with the 0, and 2 4s are 8. So the answer will be 8 pi meter, and the correct option is A. So students, next MCQ is work done by centripetal force is 0, maximum, minimum, infinite. So students, remember that centripetal force is the force that acts on an object moving in a circular path, directing it towards the center of a circle. In this case, the force is always perpendicular to the direction of the motion, means it always acts towards the center of a circle. While the displacement is tangential to the circle, it means it is along the circular path. Since the force and displacement are perpendicular to each other, so the work done by the centripetal force is zero, because according to the definition of work done, the work done is the dot product of force and displacement, and when you open this dot product there will be a cos theta, and cos will be minimum at 90 degrees, means it gives cos 90 is 0. So work done by centripetal force is 0. So the movement of earth around the sun is example of, so it's a very easy MCQ, it's an example of circulatory motion. Tangential velocity is dash product of radius and angular velocity. So students, tangential velocity is also known as the linear velocity. It's a product of radius and angular velocity. So you must have started in your classes that it's a cross product of radius and angular velocity, and whenever the two quantities are in the cross product, so this quantity is also will be the vector quantity. So the tangential velocity is a vector quantity here. So next MCQ is, a cyclist is moving in a circle with a speed of 0.3 pi radian per second. So it's a speed, angular speed 0.3 pi radian per second. Find its speed in meter per second, means you have to find the tangential velocity in meter per second if the circumference of the circle is 24 meter. So we know that the circumference of a circle is 2 pi r and it is 24 meter. So by this given information I can calculate r from here. So r is equivalent to 24 divided by 2 pi, so it will be 12 upon pi. So we know that the relation between V and omega is V equals to R omega. So if I substitute the value of R here, it will be 12 over pi, and omega is 0.3 pi. Pi will be cancelled out with each other, and 12 multiplied by 0.3. Students, see how I am going to solve this. If I remove this decimal, so there will be 10 over here, and if I solve 12 over 10, so it will be 1.2, and if you multiply 1.2 by 3, so it will be 3.6. so the correct option is B. If the radius of the circle is increased, the centripetal force will. So the students, the relation for the centripetal force is mv square over r. And if you can see this relation, the centripetal force is directly proportional to the mass and the square of the velocity, and it is inversely proportional to the radius. And they are asking the relation between radius and the force. If the radius of the circle is increased, if it is going to be increased, then obviously the centripetal force will be decreased. So the correct option is B. A sea diver draws his legs and arms in a close tuck while diving to make more somersaults. He does so because it helps him to increase angular velocity, angular momentum, moment of inertia, and all of these. So students, by bringing the legs and arms closer to the body, the diver reduces the moment of inertia. Moment of inertia is going to be reduced. This is because the mass of their limbs is now closer to the axis of rotation, which is his central body. As they tuck his limbs in, the diver's body becomes more compact, allowing them to rotate faster and more easily. This reduction in moment of inertia enables the diver to increase its angular velocity, making his rotation more rapid. So the correct option is increase angular velocity. and the relation of moment of inertia is I equals to mr square. So that if the distance reduces, the moment of inertia is going to be reduced and the angular velocity is going to be increased. Okay, so next MCQ is a fan is rotating with 4 revolutions per second. So it's angular speed that is 4 revolution per second. Find its angular deceleration when it's come to rest in 20 seconds. So the final speed will be 0 when it comes to rest in 20 seconds. So we need to calculate the deceleration. So we know that the acceleration is basically the change in the velocity divided by time. So final velocity minus initial divided by t. So 0 minus 4 divided by 20. So it will be 2 by 5 pi. So correct option is A. Thanks for watching. Don't forget to subscribe to my channel and click the notification bell to stay updated on our latest content. In our next video, we will be tackling multiple choice questions on waves as a part of our ongoing series. Stay tuned. See you in the next video.